All right, first we're going to start with a little shout out to Bill Shem, who gifted me this, I don't even know what to call it, but this cool little serape type thing that is keeping me warm because it's cold in here. Thank you, Bill Shem. All right, so we're going to talk about the theorems for inscribed angles. And the first one I want to talk about is this situation. So we're going to have several different situations. We're going to start with a circle. And on the circle, we're going to have a point. And that point is going to have two chords coming out of it. We're called the point of intersection here, A, B, and C. But I don't like the way I've drawn it, so let's try this again. We still have our point. And I'm going to draw a diameter through here, all right? And so we have A, B, and C. All right, and so the cool thing here is the measure of angle ABC. Oh, jeez. Hold on a second. All right, so angle, the measurement of angle ABC is going to be equal to 1/2 the measurement of arc AC. Now, let me show you a different way of drawing it that's going to make it seem a little more plausible. So if I were to draw this, and this is the drawing I was going for originally, and I'm going to draw diameter AB. And I drew this. We know that this arc here is 180 degrees, and lo and behold, that's a right angle, 90. That's the best way to remember this. If you can always conjure up this picture in your head, you'll be able to figure out that this is always twice the measure of this side. And the cool thing about this whole thing, this whole idea, is we don't have to have a diameter at all. We can have something that looks like this. And the same relationship will be true. If we have endpoints on the edge of the circle, this arc will always be half the distance of, sorry, this angle measurement will always be half this measurement right here. Pretty cool. Okay. As a result of our first conjecture, or our first theorem rather, if I have this circle and I have this situation, and then I were to draw this, what can you say about this angle and this angle? Well, since they have the same endpoints, showing the same arc here, these two things, these two angles have to have a congruent, or the same angle measurement. These angles are congruent. Pretty cool if you ask me. All right, for our next piece of inscribed angle brilliance, it is the situation that I was trying to conjure up the first time around, that when you have a diameter and you have your chords, this will always be 90 degrees. And it's just an extension of the rule that we had before. Finally, the last one, and it's going to make a lot of sense based on our first conjecture, that everything is building off of that. If I have a quadrilateral, no matter how I draw it, the opposing angles will always be congruent. Well, of course they'll always be congruent because they have common endpoints on the circle, and this arc will always be the same. So that's what we're kind of looking. Oh, sorry, they're not congruent. Oh, jeez, I was doing so well. They're not congruent at all because I can draw a situation that. So I'm really stuck. You can see on the whole idea of drawing diameters. So let's get off of the diameter for a second. So if I'm drawing a quadrilateral and we have clearly no diameters, what will I know about this? Well, this angle is really small and this angle is really, really big. And these two angles, I mean, almost look like 90-degree angles. I wonder, okay, I don't wonder, I know. If I add this angle and this angle together, let's call this A, and let's call this B, that the measure of angle A plus the measure of angle B is equal to 180 degrees. They are supplementary. Let's call this C and call this D, same idea. The measure of angle C plus the measure of angle D is also going to be equal to 180 degrees. That means in a quadrilateral with all of the vertices on the circle, opposite angles are supplementary. And so that's what we're going to be working with today. I would like you to give a shot for these 4 drawings right here. I'm going to keep this on one video. So pause it, try these problems, and then come back. So pause now. Okay. So here we go. I never get phone calls, of course. Now when I'm recording, I get phone calls. Okay, now we're back. All right. So find each measurement. So we know that this has a measure of 118 degrees. Find the measure of angle PRU. Well, so I know that this measurement will be half of this. What is half of 118? Well, 120 is 66, so it's 59. All right. The next one. What is the measure of arc SP? Well, it's going to be twice this measure. So if this is 75, this will be 150. All right. Fun stuff so far. It's nothing like starting off easy, right? Okay. Obviously, this drawing is not to scale. Example 2. We have this beautiful piece of artwork right here. It is pretty special. And we know, we need one added piece here. This here is 164 degrees. All right. So we are to find angle DF. Let's see, where's DF? Oh, DFA. All right, so the first thing I know is all right, so I know that this angle here is 33, which means this arc right here, I'll use a different color, has to be twice that. So if it's twice that, that means that it's 66. Okay. So I know that this is 66. I know that this is 164. All right. Great. So now what? Well, I know that this is also 66. Or sorry, 33. Because it meets at the same piece here. All right. So how are we going to do this next piece? All right, so this next piece. Well, I'm willing to bet there's a conjecture about when chords intersect inside the circle, but I can't use that yet because I don't know it yet. I'm willing to bet that's to come later. Problem is when you know that exists, you can't use it, it makes it tougher. But I do know that angle CFB has to be, no, I don't know that yet. Shoot, I really want to say that. I know that CDB has to be half of this. So CDB is half of 164. So 164 divided by 2, so that this is 82. I know that's 36, which means that I can find that angle, right? Third angle, so all of them have to add up to 180. So 82 plus 33. All right. I subtract that from 180. So I know that this angle here is 66, which means this angle is 65, which means this angle here is 65 as well. All right, so now we're getting somewhere. We know that this is a vertical pair, right? Or a linear pair. So 66, so if I go, oh, wait a second, okay, that makes sense. So that means it's 115 degrees. Because 115 plus 65 is 180. So there we go. Because we figured out this angle here, thanks to this piece. Then using what we know about triangles, we found this angle, which means we know that angle. And then finding the linear pair, we found the missing angle. Brilliant. All right, 3, find each value. Find the value of A. Oh, well, I know this has to be 90 degrees because we have a diameter here. So this whole thing is equal to 90. Subtract 20 from both sides, so 5A is equal to 70. Divide by 5, divide by 5, and we get 1. Carry the 2, so it's A is equal to 14. All right. Find the measurement of L, J, M. Oh, well, I know that this arc doesn't change, reflexive property, and this arc here, so this angle, so since this angle is creating this arc, and this angle here is also creating the same arc, we know that 5b minus 7 has to equal 3b. Okay, so minus 5b minus 5b, I get negative 7 is equal to negative 2b. So divide by negative 2, divide by negative 2, and I get b is equal to 3.5. All right, last example. Find the angle measurement for GHJK. So that's G. Sorry, here's G. Oh, so we need to find the angle measurements for all of them. All right. Well, I know this. So this is a quadrilateral. So that means this angle plus this angle has to equal, they're supplementary, that has to equal 180 degrees. So I know that 6b plus 20 plus 3b plus 25 has to equal 180. Okay, so that's 9b plus 55 is equal to 180, minus 55 minus 55. So 9b is equal to divide by 9. So we get b is equal to 13.9. All right, so at home you should be like, dude, you're an idiot, Mr. Famke. 20 plus, that's 45. All right, so if I only subtract 45 from both sides, I will get, and that's divisible by 9. Oh, that's much better. So 135 divided by 9 is 15. So B is 15. But have I answered this yet? No. We need to find all of these angle measurements. All right, so 15 times 6 is 90. Okay, 90 plus 20 is 110, which means this angle here has to be 70. It's the only way it adds up, right? To 180. Okay, on this side, 10 times 15 is 150 minus 69, and we get 81. Well, if this is 81, then, oh, I could probably do this on my own without doing this, but whatever, 99. All right, so there we go. All right, so lots of fun angle stuff going on here. And now go ahead and give this stuff a shot.